Hello viewers, now I discuss this a very interesting result in tensor calculus, that y delta ii is equal to n and delta ij b of jk is equal to b of ik, and how to use this result, and this delta is called Kronecker delta. This result is very much useful in tensor calculus, and now I discuss today this interesting result. Let's watch this video without skipping till the end. And the viewer who are watching this video first time, subscribe the channel and press the bell icon to get all the notification and latest update of my video. To prove this result, we are using the summation convention. Actually, by definition of delta ij, and what delta ij actually is, actually we are using this definition, delta ij is equal to 1 if we called I is equal to j, that is delta ii, and 0 if I is not equals to j. So by the summation convention for delta ij, for delta ii we are using, for I runs from 1, so we are using I runs from 1 to up to n, that means, and so we can write it as delta 1 1 for I is equal to 1, for I is equal to 2 plus delta 2 2, for I is equal to 3 plus delta 3 3, in this way for I equals to n delta n. So delta 1 1 is 1, delta 2 2 also 1, so all are pluses, and finally we are writing delta n 1. So here n number of 1 terms, and finally we say it as it will be treated as by n. So we can write it as n clearly. So n number of 1, so that's why it is n. So we finally prove our first result, delta ii is n, and now we are going to prove our next result. Now our next result, delta ij bjk, that will be equals to b of ik. Now we are proving this result, for we are taking I is equal to 1, we are fixing I 1, so delta 1j bjk, that will be delta 1 1 b1k plus delta 1 2 b2k, delta 1 3 b3k, and finally we are writing delta 1n bnk. And for by the definition of Kronecker delta, delta 1 1 is 1, for I is j, I equals to j, so delta 1 1 is 1, so 1 into b 1k, delta 1 2 is 0, so 0 into b 2k, delta 1 3 is 0 into b 3k, in this way we are writing 0 into bnk, and we are finally writing 0 for b1k. So finally we are getting delta 1j bjk is equal to b1k, and next for I is equal to 2, similarly we can write delta 2j bjk, that is delta 2 1 b1k, delta 2 2 b2k, delta 2 3 b3k, and delta 2n bnk. Here also we are writing for delta 2 1, that will be 0, so 0 into 1k, delta 2 2 is 1, so 1 into b2k, delta 2 3 is 0 into b3k, and 0 into bnk. So we are writing here b3k, b2k, sorry. So delta 2j bjk is equal to b2k. So in this way we are writing, similarly for I is n, so delta nj bjk, that will be delta n1 b1k, delta n2 b2k, delta n3 b3k, and delta nn bnk. So 0 into b1k plus 0 into b2k, 0 into b3k, and 0 into 1 into bnk. So we are writing bnk. So finally if we are generalizing this result for I is n, so finally we are writing for n is equal to I, we are writing easily, we can say that it will be delta ij bjk is equal to delta 1k. Here for we are proving by induction method, this result is valid for I is equal to n, and if is 2 for I is n, then easily you can writing this result also hold for I is n plus 1. It is also true if we are taking this result for I is n plus 1 and generalizing this result. If we take for I is n plus 1, so we are writing here also b n plus 1 j b of jk, that is b of n plus 1k, in this manner. We are similarly proof for n plus 1 1b jk for j also runs from n plus 1. And if we are generalizing this type of result, actually we are fixing here for j runs from 1 to up to n, that's why we are going to write here in this manner. We are going to write here in this induction method, but this also valid if we are taking for j also runs from n plus 1. So if we are writing, if simply say that's a generalization of this result, we can verify our quantity. And if someone arguing that why j runs from n plus 1, it is the extension further. If we are taking we are taking already here all this perspective, all this component as 1 to up to n, but if we are taking the further extension n is as n plus 1, this result also valid. That's why we can say this result is also valid for n plus 1. Here we are taking j from 1 to up to n plus 1. This is our explanation, not n. So we are simply already proved this result also valid. So after the generalization of this result, we can say this is true. In this way we end our discussion today. If you like this video, like it, share it, and always subscribe the channel. Thanks for watching.